Okay, in this video I'm going to show you how to breadboard a circuit. In this case it's a 555 circuit, and I've got a schematic up on the top here and a breadboard and all the parts and the wires that we're going to be using for this. So first let's take a look at this, the IC, which is the 555 timer. One of the things that's super important is knowing the orientation of it, and you can see a little notch on the top. I'll do some zoom in shots a little bit later so you'll be able to see this a little bit better, but there's a little notch on the top, and that corner indicates that that is pin 1 on the device. And that's going to be important when we use it in the circuit. The other thing you'll notice too is that the leads are kind of bent out at an angle, and that's because typically when these are put into systems, electronic circuit boards, they use a robot to actually, some kind of robotic system to insert the parts in. So those pins being bent like that actually act as a spring. So what I'm going to do is set that into the breadboard. So what I usually suggest is putting the component, the main component, towards the center of the board. And like I just mentioned, that these leads are kind of bent out. So what I'm going to do is I'm going to actually kind of push them on the surface, on some flat surface, and straighten out the leads. Hard to see here. Straighten them out so that they'll plug into the breadboard a little bit easier. So I'm going to plug that in, making it again sure that that notch towards the front end of it is to the left on the board. Next, what I'm going to do is wire the power supply pins on the device. I usually do that because it's something, for some reason, it's kind of left off and easily forgotten. And if you take a look on the schematic, you can see that pin 8 and pin 4 here are going to the 9-volt supply on the top, and pin 1 is going to ground. Now, traditionally, the colors that are used for ground are black, so I'm going to take pin 1, plug that into the breadboard, and plug that in there. And that blue strip along the bottom is called a bus, and that's what we're going to be connecting our power to. All those terminals are connected together. You should have seen that in the video from this unit. And then pin 8, in this case, is positive, so I'm going to plug in that red wire there and plug it into that strip. Now this breadboard has these blue and red lines run the entire length. Sometimes there will be a gap, in which case you'd have to run some little jumpers across to make sure they're connected. Now, once I've done that, what I'm going to do is grab my marker here and mark off the connections I made. I do this all the time. Even after working on even simple circuits, I will do this all the time because it's too easy to leave off a connection and miss something. So we also see that pin 4 is also connected to the positive wire. And there are a couple ways that we can do this. We could either take pin 4 and jumper it over to pin 8 like this. That's one way to do it. Okay, where that's going from 4 to 8. Or, because this whole strip is powered, we can just run the wire over like that. And that might be a little bit easier because you're going to see that the wiring close to the part itself is going to get kind of congested. And I'll mark that off as I go. Okay. The next, so that's the power for the device, and I want to make sure that was done first. Let's go ahead and start on the right side of the schematic over here that's connected to the LEDs. So I'm going to take a wire, and the output pin here is pin 3 on the device. So I'm going to plug in here to pin 3 with this yellow wire. And I'm going to come over quite a ways here to have lots of room to work with. And you'll see kind of why I'm doing this in a moment. Now if you look carefully, you'll see that I already made a mistake, and partially because I'm trying to watch the screen at the same time. But this is not plugged into pin 8. It's supposed to be. But it's actually, I have it plugged into pin 7. These rows are pretty close together, so you have to make sure you're plugged into the exact row that you're supposed to be connecting to. Otherwise, the circuit won't work. Okay, let's continue on with the next part. So on the far right, on the top here, we've got this 1K resistor. One side is connected to 9 volts, the other side goes to the LED. So I'm going to take this resistor and the leads. Leads are kind of long. And I'm going to connect one side to the positive and the other side over to another point on the breadboard right here. Which pin you actually go into isn't critical, but the main thing is that that red wire on the 1K is connected up to the 9 volts. So the other side has to go to the LED. In this case, the LED on the top is green and the bottom is red. Sorry, I don't have a red marker. So I'm going to take this LED and I'm going to bend the leads a little bit. With the LED, a couple of things that are important. The longer lead, and if I straighten these out, you can see this a little bit better. The longer lead is the positive lead on the LED. The other way you can tell is that if you look at the LED itself, kind of there's a lot of more metal on the negative terminal, and there's what's called a flat side on the edge there. So what I'm going to do then is take that LED, plug the positive in there, and the negative side over to this point in the middle. So now I've made this connection here. I've got the resistor connected to the LED right there, and then the LED is connected to the same connection pin as pin 3. So it might seem a little tedious to be kind of marking these all off one at a time, but I can honestly tell you it's going to save you a lot of grief when you're trying to do a more complex circuit. Okay, so I'm going to bend the leads for the next resistor here, right angles. Okay, and the way I'm doing this is kind of arbitrary. You can kind of pick any way you want as far as wiring this, but I'm just showing you one simple example here. So we now have the second resistor there, and that's now connected to pin 3. And then we have to connect that to the LED that goes to ground. So here you can see with this LED, it's a little more clear that one lead is much longer than the other. That's the positive lead, which is called the anode right here. I'm going to connect that and then also connect to ground. Now, for those of you who are into aesthetics, you might say, well, those aren't lined up very well. It doesn't look like the schematic. That's okay. I'm just trying to do this to test the circuit. And if I pull this lead forward, you can see that that's connected to the negative terminal. So now I've completed this part and this part. Now we're going to move over to the other side. Now, I'm going to start with this top resistor, the 1K resistor, okay, brown, black, red. And it's going to go from the red and it's going to connect to pin 7 here. Now, what's interesting, though, is that it is connected between pins 8 and pin 7 here. There are a couple of approaches you could take to this. I could bend this wire like this at a right angle and then trim it, and it'll plug directly into the IC itself. And I'm going to do that. I'm going to grab a wire cutter. Okay, so I'm going to clip that wire short. You don't want to make the leads too long, maybe 1/4 of an inch at the longest. And now what I'm left up with is that resistor with these kind of shorter leads on it. Okay, and that is going, if you look carefully on the schematic, that's really going between pins 8 and pin 7 on the IC. So in this case, I can just plug it in directly to those terminals, or the spring clips right there. A little hard to see. If I turn it sideways, you can see it a little bit. And again, I promise I'll zoom in a little bit later so you can see how this whole circuit looks. So now I've done 8, and that's going to 7 there. Okay. Next, we've got pins 6 and 2 are connected together. So I'm going to put a jumper wire there to connect those 2 pins. Going from pin 2 down here up to pin 6 up to there. So we connected those 2. And we have another 1K resistor that, in this case, if you look carefully again, is going from pin 7. The schematic is a little hard to read here, but it's really going from pin 7 here back to pin 6 or pin 2. So I can do the same thing. I'm going to bend the leads, clip it about that long, and plug that into 6 and 7. Now the other alternative is I could have easily also just spread the wires out kind of like I did these resistors. That would be totally fine. I'm just trying to kind of save a little bit of space as I'm doing this. So that resistor is connected to pin 7, and we're coming back up here, and it's connected all the way to 6 and 2. Last component we have is this capacitor, and here's the capacitor. Okay. Now with a capacitor, same thing. This capacitor is polarized. That kind of white band, that long kind of bar, indicates the negative side. And usually if the leads aren't clipped short, the longer lead would be positive. So that's another way you can tell. So in this case, though, if you look carefully, I've built this circuit many times, so that's kind of a shortcut here. We see that pin 1 is connected to ground, and the capacitor is connected to pin 2. So we can literally go across pins 1 and 2 here. It gets a little tight. I'm going to move one of the wires down a little bit here. But now I can take that positive terminal connected to pin 2 and the ground side to pin 1, like that. Okay, and that completes our circuit. And again, there's no problem in spreading out the components if you want. Using more jumper wires, that's fine. In fact, a lot of the time I'll clip wires, shorter wires than these. Okay, now what I'm going to do is zoom in on the circuit so you can see a little bit better. Okay, so this is a circuit now, and I'll move this one wire down a little bit so it's a little bit more clear. It's a little bit messy. It's not perfect. And certainly if you used your own jumper wires and maybe spread things out a little bit more, it'd be a little bit more clear. But hopefully you can kind of follow the pattern that I'm going through with all these connections here. Once again, I realized, because I was kind of going fast here, that the connection that is supposed to go to pin 6 is actually going to pin 5. You'll remember the way the pins start is 1 on the bottom left corner, 4, 5, and then all the way around to 8. So this one should really be going to pin 6. So when I finish one of these circuits like this, when I'm breadboarding it, I always will go back and double check all the connections. It's one of those things where you measure twice, cut once. The more time you take to check it before you hook it up, and realize, for example, if you hook up the power backwards or something, you could easily damage the devices, or you might just have to take a lot more time to debug it. So this is important when you're prototyping these circuits. So let's power it up and see what happens. Okay, so I've got a 9-volt battery here with a battery plug on the top, and I'm going to plug it in. We're going to see if this works. Hopefully everything will work fine. You'll notice a couple of things here too. I have these jumper wires connecting the bottom to the top, and I do that so that I can just connect the power strip on the bottom. So let's see what happens here when I power this up. I can plug that in. If you remember watching the breadboard video, the guy does the same thing with these stranded wires. It doesn't work well. Okay, they're flashing pretty fast, at a fast rate. I can change that by swapping out one of the resistors, which I'll do here. Okay, there we go. So I plugged in a 10K resistor. And the other way that we could, the flash doesn't look very synchronous because the refresh rate on the camera probably isn't very good. We could also slow down the speed rate by using a larger capacitor. And that's something more of an ELTN 130 topic. So why do we go through the trouble of this? Well, a couple of things. One, we want to proof out that our schematic that we created here is correct. You always want to make sure your schematic is correct because there are many, many processes for building a circuit board. And if you catch a mistake early on, that's going to make it a lot more, well, it's going to work. It's not going to have problems that you'll have to troubleshoot at the end. Or if you have a mistake in your schematic and you create your board, by the end, you could have a completely defective, non-functioning product. So I always recommend, even with basic, simple circuits, to go through the process of breadboarding the circuit to make sure it's correct. The other thing, too, is that this gives us an opportunity to play around with some different values. For example, I'm going to put a larger capacitor value here. I usually wouldn't do this with the circuit live, but I'm not too worried about it right now. Okay, and now we can see that we have a much slower flash rate. If I turn off one of my lights here, you can see the kind of the colors, the LEDs flashing a little bit better. So that's just kind of an introduction to breadboarding. Takes a little bit of practice, especially with more complicated circuits. But if you go through this process of crossing off the connections and again double checking it, like I had a couple of mistakes, you want to make sure you catch all those errors before you actually commit to finishing the circuit board itself.